Still um, in the early stages. We're still in the early stages developing our MVP. So yeah, maybe before the end of this year, I'll talk more about that one. But yeah, let me get into Bloc, right? So I'm sharing my screen now. If you have any issues seeing my screen, let me know. A sec. Alright, can everyone see my screen? If you can see my screen, just drop comments in the chat box. I don't know why it's weird like this. Okay, it's very strange. Alright. Yeah. So I'm going to be going over some pretty basic stuff about Bloc, right? I was thinking of making this more than a one-part series because, I mean, if I want people to understand how to use Bloc, I'm going to have to start from scratch, right? And get into the more advanced stuff, right? Without chasing away anyone that doesn't know so much yet, right? So, what's Bloc, right? What's Bloc state management? What's Bloc? Bloc is a state management technique, right? It's an event-based state management technique, right? What that means is that um, you have states, right? You have your states. You know how you have your set state. You have your states in your stateful widgets, right? Um, if you're trying to manage states that way, it might get a little bit confusing and quite spaghetti like. It's going to be so much, right? So when you have a stage management technique, you are basically delegating, you are telling this system to handle your states for you, right? You're telling it to do some of the heavy lifting and separation. Like you don't want to have to handle all those cases yourself, right? That's why you do stuff like that. And most of the time, you would have to use state management techniques when you work for companies, right? It's not a personal project. It's a project where a lot of people are going to be working on it with you, and future developers, engineers are going to work on that same project. So they can't not use a state management technique. Right? So Bloc, I said, is an event-based state management technique. What that means is that um, you trigger events and it gives you the states for that event, right? Let me let me break it down a bit, right? So if it's clear, because I'm not sure if I hope everybody's hearing me though. If you can hear me, let me know. Let me know, please. All right. So yeah, as I was saying, Bloc is an event-based system, right? What that means is that you trigger events, it gives you its states, right? And then there are two what do you call it, state management techniques inside Bloc, right? There's the qubits and you have the Bloc. Um, qubits are let me see. Um, Qubits are a more basic form of Bloc, right? Bloc actually extends qubits and actually adds to it. It adds the events to it. So Bloc is an entity on its own, and qubit is an entity on its own, right? Qubit doesn't deal with events. It doesn't deal with events. Blocks deal with events. You trigger those events, and it gives you something in return for the event you triggered. So yeah, so qubit is like a lightweight version of a Bloc entity, right? So let me not talk too much. I'll be going over some of these things to make sure that it's clear. So I'm going to create a project now. I've actually created the project already, and we'll just go over like how to set up Bloc, right? And I'll return back to the theory behind this, right? So yeah, if you want to follow along, you can. I'm not going to rush it, and if you can't see my screen, like the text, let me know so maybe I can zoom in. Yep.
Is it possible to zoom it a bit so that we can actually see clearly?
Is it better now?
Uh-huh, this is perfect. Yeah.
All right. I think it's quite big. So we're going to be adding the Bloc package. This is like a fresh um, Flutter app. Like you normally create. Let me see. Where's you can run Flutter create your project, right, and open it up. So this is like the boilerplate. This is the normal stuff you get when you create a new Flutter project, right? So let's add the Bloc package, and I'll come back to the theoretical part. That is the basics. Like you need to understand the basics before you start trying to cook with it. So let's add Bloc. Uh, add Flutter Bloc instead. So this. You can follow along. If you're having any issues, please let me know. That this right. So should be added now. Let's see. Okay, so we have Flutter Bloc right here now. So go back to this place. Right. So we if you want to set up your Bloc state management, you want to set it up from the scratch, you could do this, right? Create a new Flutter project, add Bloc to it, or you could use the Very Good CLI. I think you might have heard about Very Good, and there's Very Good Ventures, and some of the packages they make, right? So yeah, the Very Good CLI, right? This one helps you generate a lot of boilerplates for you, right? So you don't have to go out and go. You don't have to set it up by yourself. A lot of boilerplates, right? But I want to do this so that you actually understand how to set it up without the CLI, right? So yeah, let me get rid of some of these things. It's quite big for me. Let me see what I'm doing. Let's see. This. 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 So I want to create just a fresh page. Let's call it package. Um, let's just call it counter for now. I'll change it later. So I want to hook up like I want to set up my Bloc, right? So I'll just be going over the stuff, right? So check. So first of all, what you need, right? Um, before you start setting up, before you start using the Bloc, right? You could do without it, but doing this actually helps you like see the events and states being triggered, right, in your Bloc. There's something called the Bloc observer, right? The Bloc observer is in charge of. Let me define it here. The Bloc observer, yeah, is in charge of what will I say? It's like it's a class that helps you track the events, errors happening in your blocks, right, globally, right? So if you've used Bloc before, if you haven't, I'll still explain how. But if you've used Bloc before, you see a lot of logs in your terminal showing you events that happen in states and stuff like that. So Block Observer um, is like what helps you read all the blocks and qubits in your app, right? It allows you see the states and everything happening. So you're not just doing something and you're lost how it happened, right? It's showing you how it happens. So let's find this um, chocolate app. Chocolate app. So let's extend it, and then you override some of the methods, right? So it has this on events. You have the on error, right? And some other stuff, right? On change, on transition, stuff like that. I'll go over this stuff. I don't want to make it so complex because I want to make sure that everyone understands what's happening too. So, uh, the block observer, you could do without it, right? But it's good for actually keeping track of stuff that happens in your block, events, errors, and stuff like that. A change in states in a particular block, stuff like that. So, yeah. So when you have this block observer, you have to set it up. Set it up right here. Server, see this, right? Yeah. So basically, you are saying, yeah, giving your implementation of the block observer as you extended it. I think everyone here knows what inheritance is and how you can extend a class and like provide your own implementation of that class, right? So when you extend a class, you get its default behavior, and then you provide your own behavior to it. That's what you call inheritance, right? So I'm inheriting the behavior of a parent, and I'm giving the child, right, the uh, sub class, right, like say app block observer, right, we are giving it its own implementation from um, the parent class. Hope that's clear, Shaka. Yeah, I think it is. So when you do this super dot on event, you are saying, give me the implementation from this parent, right? Like my father, I want his behaviors, and then I want to give my own. I want to add my own behaviors to it, right? So that's basically inheritance. So that's what we're doing here. We're now giving this block the observer, right? Right. We're giving it our own implementation of it to this block observer. We're giving it our own implementation, and then you can do some crazy stuff in here if you want. But yeah, I think is that clear? Let me just be sure. Sorry. Hold on. Some people in chat box. I guess someone with zero knowledge of block can't follow up. Sorry, Francis. What do you mean? You can speak if you so that I could, because I'm trying to make it as basic as possible, right? So at least you need to understand. Um, okay, why not? Okay, okay, all right. So that's the thing about this. You need to have the fundamentals of that Flutter checked, right? And then I'm trying to like make it as clear as possible to everyone about the block basics. I'm still going to go over the basics of it. This is me setting up my um, block to do some stuff in it. So, right, yeah. So, okay. All right, let's continue, right? So we've had the block observer set up, right? So this allows us to do some stuff. We can log stuff. Right? Yeah. Let's continue, right? So let's see. Let me go back to my block, right? So I think I explained block, right? And qubits, right? Block is an event, is an event-based system, right? You trigger events, it gives you states. Qubit, on the other hand, is it's just like a simpler version of block. It doesn't have events. I'll show you what it does instead of events, right? It's kind of basic, right? So yeah. What else? Okay. Let me go over some stuff. Let me see. Should I use block? Blah, blah, blah. Okay. Let's continue. Block, right? Okay. So there are two ways that you can generate your block classes, right? You could do them manually, or you could install an extension. But I'm going to do it manually, right? You could install this extension. Is was made by very good CL, very good to make it easier to generate block classes and qubits, right? But I'm going to do it from scratch, so you know what's happening. Let's see. Let's create a new folder. We'll call it qubits, right? And so we're going to start with qubits, right? And I'm going to do some interesting stuff with it this time. Counter qubit. Yeah, basic version of it. Wait, sorry, I'm not going to generate that. I'm going to do it from scratch. A new part file. Counter qubit. So we're going to create a class, right? We're going to call it counter qubits, and we're going to extend qubits, right? Qubits, right? And I know everyone knows the counter example, right? Where you have a number, you increment and you decrement, right? So um, it's kind of basic, right? So that's why I actually thought of making it more than a one-part series, because to get to the advanced parts, you might need to understand the basic stuff, right? So when you have a qubit, you have a state, right? It doesn't have events like blocks. So you can define what your state looks like. In this case, a counter, this thing is an int, right? In a basic counter example is we are trying to manipulate one particular state. That's a number, right? An integer, right? So that's when you do the plus one, minus one. But when you start handling more complex states, you have to define a class, right, that holds more states that you want to manipulate, right? But let me go over this one first. So a counter qubit, right? So counter qubit, you want to construct your class, right? And you want to give your class a initial state, right? You want to give your qubit an initial state for this class. So we have an integer, right? And you a counter example will start from 0, right? So we want to give it an initial state, and then we want to increment and decrement, right? So when you do super, right, you want to give it an initial state of your so the way qubit works now, let's get into qubit. I was talking about block and event-based system. So I'm going to talking about qubits now. So qubits are a simpler version of block, like I said earlier, right? They don't have events. They just have methods. They have the variables, methods that you can call, like your basic classes, right? You know, when you want to call, say, when you want to get something, right? That's what qubits is. You have methods. You call them, and then you get the states for it. It emits those states. So I'll show you how that happens, right? So in a basic counter application, you have this void increment. Right? I hope it's clear. Let me check. Okay. If it's clear, let me know. If it's not, say if you want to ask a question, you can go ahead and ask. No questions. Okay. So increment, right? Um, you want to increase the value, the current state, right? So this state is an int, right? And you want to increase it, right? So we go this. Let me see. Something is there. Okay, I can't set this state. Sorry. Give me a sec. Yeah. Um, so we want to increment the states, right?
You have a question in the chat.
Why did you pass 0 to the superconstructor? Yeah, so when you when you create a qubit or a block, there's an initial state. There's an initial state your block has to have, right? So when you do super, right, you want to give it an initial state. Now we are doing the basic form of a counter example. You know a counter example, you increment and you decrement, right? And it's always starting from 0. So our state here is an integer, right? The current state is what? What do you want it to have when you create it? 0 in a normal counter example, right? You have 0 and then you want to increment or decrement. It could be something else, right? So I don't want to go into the more advanced parts. I want to talk about the basics of block, right? So I'll show you an example. Okay, you can go ahead to ask, right? You can. I think you can unmute, right?
Hello, can you hear
Yeah,
me?
yeah, I can.
The question I want to ask is, using this qubit, I don't know if it applies to block in general, does it mean you can only alter the state of one thing at a time? Like,
No.
for example, in this counter now, you have one field that is at increment and decrement. What if you have two fields? You need to create a different qubit to control the other one.
Yeah,
Because unlike
yeah,
other things, you can have say in the provider, for example, you can just create two variables and just manipulate them within the same class and
yes.
all the
Hold
type
on.
is not and everything.
Yeah, I get your question, right? So now that's what I was talking about initially, right? The state we are trying to manipulate, it could be a class, right? You can define a class. I don't want to. You can define a class, say a counter state, right? And you can give it like variables in here, right? Say int. I don't know what to call it. Something like right, and pass it into this space, right? And then manipulate those things here, right? And then you can do stuff like state dot number, right? And change those values inside this. So it doesn't have to be just one thing, right? It could be a lot of things. But I'm trying to give you the counter example version of this thing, right? So state version, you can see that I can manipulate other stuff inside this state, right? So yeah, it doesn't have to be just one thing, right? But I want to do the basic stuff first. You understand? I hope that's clear. I hope that's clear. I think it's clear though. I'll get into this that you can like so you can understand what I'm trying to say. So back to where we were, right? You see a counter example, you want to increment and decrement. So you want to say this. I guess if we it's, I can't set it. Sorry, give me a sec. I think I might have forgotten how to use this. Sorry, give me a moment. I just want to be sure because I think I forgot how to manipulate qubits. I want to quickly open a project and see something so I can. Oh, that's weird. That's exactly what I'm doing. Right? A plus 1. Oh, okay. That's weird. What was I doing before? Sorry. Yeah. So, you know the increments, the decrements, right? When you do a basic, when you're doing like a basic counter, right? Decrements, the increments. My head is far past qubits, and I've forgotten how to do the basic stuff. Yeah, it's terrible. Yeah. So yeah, increment, decrement, right? So this is you manipulating a particular state, right? And now you have your counter qubits, right? And then if you want to access this counter states and its qubits, you have to use something called a block provider, right? Uh, yeah, state plus plus should work. I don't know why it was giving me that issue. It's no, sorry. Give me a sec. It's emit, sorry. State plus plus should work. I don't know why it wasn't. Oh, anyways. Yeah, I'll come back to that. I don't know. I think I've forgotten why it doesn't work. So, say you want to access the values of your counter qubits now, right? The current states. There's something called a block provider. I think most people have used provider, right? You've used provider. You know how you have to read a particular provider, say change notifier, right? And um, you want to access your change notifier and do something with it. I think everyone knows what a provider is, right? So normal provider, basic provider. So basically, what happens is Block builds on provider. It has some of those basic functionalities of a provider. The same thing with Riverpod, right? You have those things that it uses, right? Context of read, context of word, context of select. So let's get back to accessing this, right? So say, let's call this a scaffold, body, colon, child, and the text, right? So we want to, let me add a button here too. Sorry, let me just call it the video button. Call this, let's do this in that text. So if you can't see it, let me know. Okay, you can see it, sir. So now I want to define, I want to create the UI. So we'll run it and see how this works, right? And then I'll go back to the theory, right? So you need to be able to understand why what is happening, right? Because you can't just jump into the middle and you'll be confused. Very, very confused, right? I had more that I wanted to talk about, but because this is like my first time doing this, I'm kind of not so sure how this stuff works. So yeah, so you want to access your counter qubits, right? Like the way you do a block, a normal provider. There's something called a block provider, right? You want to access the states and functionalities of a particular um, block or qubit, right? There's something called a block provider, right? So all these things come from the extension. Like I said, I feel like this should be more than a one-part series, but well, let me just continue. So a block provider, right? You have a block provider, and now what we want to do is access the states in that block, in that qubit, right? So the block provider has a create field, right? What should I call it now? Yeah, it's a field where you supply what qubit or block you want, right? So what you would do is now we have counter qubits, right? And then we have how we're going to access those variables in counter qubits. If you've used provider, I'm probably sure you're familiar with some of these things, right? So yeah, let me just do that. So now what we've done here is we've given ourselves the what do you call it, the functionality to actually access the states in this counter qubits, right? And then if you want to access those values, you need to be able to read it, right? So I'm going to do something to access those states. You're going to have to wrap your so say we want to read the current value, right? This integer, we want to know the current value of it, right? This current state. There are ways that you can access states in a block or a qubit, right? Uh, there's something called a block builder, right? A block builder. This is a block builder, right? A block builder takes two things, right? Your qubit or your block and the state that you want to listen to, the state you want to react to, right? So now in this case, um, our it might get confusing that they created a widget called block builder and you want to access qubits. It might be confusing, but it's not confusing. When you have a block builder, you could access states in a qubit or a block. It's not fixed that it must be a block, right? So in this case, now we have a counter qubit. We can, so um, I think you guys might, I think you know what generics are. I don't know if you know, but it might be confusing. Don't be confused by the term generics, right? Generics are just a way to define um, different types of a particular variable. You want to have, um, should I say, I'm not going to it, but yeah. So a block builder takes two things, right? A state and a block builder takes a block or a qubit and a state. So now we want to take counter qubits and the states. What's our state? Our state is this. It's an integer. If it was a class, right? Say class counter states, right? If you add this, right? We will be if we put this here, right? We would access counter states here, right? It will be counter states. But in this case, it is an integer, right? It's an integer. So you need to do what? Change this to an int, right? So now when you've wrapped this with a block builder, you have something called state. This state is the current value of your integer. You can, if you hover over it, I think everyone is following. If you have any questions, let me go back. Yeah. If you have any questions, let me know. So state, right? This state is the current state here, this value, this int, right? So you could rename it if you want. You could call it current number value. Let's make it current number value, right? And that current number value has an initial state of 0, right? And you can increment or decrement, right? What emit does, we'll get into what emit does and why we have the block builder. I think I explained what block builder does. It allows us to access the states in our qubit or block, right? So the states that we're trying to access is this integer, right? Now, what does emit do? What's the work of emit, right? It's kind of, I don't know how to put it, right? It pushes the current value to any widget that is currently listening to it. It emits, it shouts that this is the new value, right? If you are listening to it, updates, right? I think that's clear. So what emit does is shouts it the current state. In this case, it's the number, right? It shouts the current state to anyone that is listening to it. This is my value. Reacts to it, right? And what we're doing here is reacting to those values, right? This current number value, right? This state, we're reacting to it. So anytime we increment or decrement, it's going to tell us what the new value is, and we need to absorb this value. We need to read what the value is. So what you do is, I think everyone knows what interpolation is, but we don't need it. So string interpolation, right? If you have a string, you can do this and then access this, right? So you can say number. Yeah, you can do this. I think you know what string interpolation is. So yeah. So now what's happening is anytime we increment or decrement, is this value is going to change. Right? So let me run this. Let me run the sheet. Simulator. Let's open this. Let me check the chat box if anyone has a question for me. Yeah. Right. So now I want to run this because so after this, I'll go back to the theory, right? And then I might decide on whether or not I will make this a more than one part series so that we can do more complex stuff, right? But I think ultimately this actually gives you the basics of block and qubits, right? So we've not gone into block because that one is more complex. Qubits is a simpler version of it, right? So let's as this builds, let's see. We've not done the incrementing functionality yet, so I want to show you what the current value is before. Okay, let me center this. Center this. Okay. Oh, sorry. Main axis. Okay. So you can see we have the number. The initial state is 0, like I defined here. If I wanted the initial state to be 15, I think I might need to rerun this. Yeah. So you can see that the current state changed to 15, right? So this is where you define your current states, right? So I think it was Teslim that asked, I don't know if it's still here, but the question Teslim asked about having multiple states inside it, you have to define a class to actually handle more than one state. Well, I'm handling just a single state, right? So yeah, number 0, right? And now we want to increment or decrement. You can see that nothing happens when we increment or decrement, right? So we need to do that functionality. Like I said, provider, if you've used provider before, you know what you call context or read, right? So context or read is actually an extension on build context. If you go into the actual functionality, right? You see that it's an extension on build context here. Read is a method called read. And if you've used provider before, you know provider.of, and then I think you know how this. So this thing is just like a wrapper on provider, right? So it should not be confusing. It actually uses the provider package. So yeah. Now we want to read what our counter qubit, right? So you have to define the name of your block or qubit. So this qubit, right? And then we want to access the behaviors, the methods inside this class, right? If you don't do this, increment is not going to be there. Like it's probably going to work, but I doubt it's going to work. It's not going to work because what read does is to actually check your widget tree if there is a defined class in your widget tree. I think you know what a widget tree is, right? So in this context, right, this widget tree, it goes up, context tree goes up, and it goes to check can you give me the values of this class? But you didn't define a class, so it doesn't know what value he's going to find, right? It's going to fail to find the value. So when you do this, and you've already defined block provider above here, you supplied your widgets, your class, right? Counter qubit. Now, if it goes up, context of read, when it goes up to look for the value, the class, it's going to find counter qubits, right? And now the method increments that you defined inside this, right? You can now call it. You can call those that method, right? So we're calling increments. When we increment now, it's going to change the value, right? So increment, like. So as simple as the counter example is, if you do not understand the basics of block, right, you'll be lost when you see it. It look like it's just a counter example now. You're like, it's easy, it's so simple, right? But a lot of things could go wrong if you don't do the right thing when you're using block, right? So yeah, now that we have that, we could define our decrements. I think decrements, right? So if we increment, we decrement, increment. That's basically a counter, right? But you are using qubits to handle this, right? So yeah, that's kind of like the basics of this. I think, yeah. So I want to show you what happens when you do this block observer thing, right? So we want to, what I think I explained what block observer does, right? It allows you to read the states in your blocks, right? It logs it. You can log it. You can do anything inside there, but let's log the values, right? So let's do debug print. Say, I think it has something called stack trace. Yeah. Let's go ahead and log the block and its events. Yeah, let's do block. And events. Right? It should work. Yeah. Wait, no. Dude, this is not because we're using qubits. We want to see a change. We're not using a block, so it's not going to work. So let's do change, right? So I think if I should, sorry, if I increment now, yeah, exactly. So you could see in the console, right? What this app observer does is observe your blocks, your qubits, right? The reason why I didn't do it in on events, right, it is a different functionality. When you use blocks, I said you have events, right? So when you trigger an event, it's going to log those events for you. But we don't have a block, we're using a qubit. So defining anything here is not going to work. It's not going to work because it's not a block, it's a qubit. On change, on the other hand, works for both block and qubit, right? So now when we increment, we decrement, you see that the state changes. It tells us the next state, blah, blah, blah. That's that for that. Sorry, let me see. I didn't hear your answer to my question. What advantage does block have over qubit? Yeah, I'm going into that. I think I've gone over qubits, the basics of qubits. So because this is meant to last 1 hour. So let me go into the theoretical parts and so you could understand what the advantages of block, qubits, you know. So let's see. He asked the advantages of block versus qubits, right? So as you obviously improve, right? As you improve in your engineering, what should I call it, development, right? How you as you work, as you learn, right, you would realize that things get a bit confusing. It gets complex. A lot of things are happening, right? And you want to be able to handle them in a good way, right? So why should I use block and qubit, right? So qubit is a simpler form of block, right? It has its advantages and disadvantages, right? On block, on the other hand, is obviously has the advantages and disadvantages, right? So why should I use qubits instead of block? Qubits allow you to handle very simple states, simple events, things that you don't need to, um, how should I put it? You don't need to react to anything. You don't need to react to so many states or stuff like that. You don't need to. Block, on the other hand, right? Say somebody just finished signing up, right? Someone just finished signing up. You could do this with qubits, right? But I want to show you a case where block signs. If someone just finished signing up and you have, say, an animation or a snack bar or something that needs to pop up, right? So block, it has events, right? You can add those events when something happens, right? Qubit, on the other hand, has methods, right? Those methods you have to, they have a clear definition. You can't just call them as you wish, right? If you call them, if you don't call them properly, you have like issues. I could go. I don't want to go into some of those issues, but basically, if you have like an animation or something, and you want to trigger like different states of that animations based on your uh, the person signing up, you have events. Say the person logs in, you want to trigger an animation inside that thing, you have an event. Now it's successful, right? You can throw in a successful state of that animation. You could throw in a snack bar so that pops up when that animation, when that login is successful. Now you have two things that is happening. You have an animation that maybe smiles when you log in, right? And you have a snack bar that pops up too when you, what they call it, when you log in. So those things are like kind of the reasons why you use block instead. You have more complex states you want to handle, right? So you should use block instead. If you use qubit, you can use qubit, but it might get a bit confusing, and there are restrictions there. There are events and some other stuff that you can't possibly like, So that's just part of it. I think I answered it. I'm not sure if he's still here. Yeah. So I think I went over two things, right? A block provider, a block provider, and a block builder. Yeah, like other methods inside this thing. But like I said, might get a. If I go into a lot of those things now, I don't think we have enough time to right now because it's meant to last for an hour, right? So I was meant to talk about some other stuff, I guess. No, maybe not in this session. Miriam, can you help me out here? What we do now if we want to continue this? Because it's Miriam there.
Okay, what do you need?
So like I was saying, I went over like the simple, like getting started with block, right? But yeah, like some other stuff that we'll talk about. I don't know if we can talk about it in this class or we need to delegate it into a different class.
Um,
Yeah,
okay.
maybe later.
I think we can talk about that later. Yeah.
Yeah, yeah. So, does anyone have any questions? If you have any feedback, um, yeah, you can go ahead and
Someone is
unmute.
raising his hand.
Yeah, unmute and ask.
Um, sorry, good evening, good evening. Can we
Yeah.
address the reason why state plus plus didn't work? Because I've been in a situation where I was dealing with a value too, and adding
That's
into
very
it
well.
plus plus sign wasn't working. And
So
I
I
mean,
think
because I'm kind of interested in it because it was happened to me before. So,
okay.
because it's a personal
Yeah.
thing, I want to know why.
Give me a sec. So states is actually immutable. So when we do states plus plus, right, we are trying to change the value of something that is immutable. I think if we do, let me see if I can. I think I tried states plus one, but it didn't work as well. Give me a sec. Okay, let me try something. Right, so I see states plus plus ish. That didn't work. I'm not even sure. See, obviously this will work. But why doesn't state plus work?
Maybe because we did not declare like assign it to a value before we passed it through the qubit class.
Okay. This is actually getter. So you said, let's see if I can figure out this. You said maybe because we didn't pass it into a variable first. Let's see. Let's see. Qubits. Okay. So normally, right, what you would do, right, because this state is actually immutable. So if you had, like you said, if you had a counter state, right, and this counter state had a final variable, say current number, right? So the thing is, state itself is actually not, the value is not mutable, right? So what we're doing here is we're adding 1 to it, but you can't set the value, right? We're just adding a number to it. But like you said, if you were going to do this, what you would do is create, should I say, copy with, right? Which actually updates the value itself, right? I think you know what copy with is. Let's see. Yes. Then we have copy with, right? Counter states copy with. So we want to change the value, right? So yeah, or I call it int number, right? It's variable. So we want to do counter states and then do current number, as in that current number, right? And then return this. I think this should work instead for the case. Counter states, counter states, and then define 0. And then I can do state dot current number, state dot with, and give it a current number, state dot current number plus. No, 1. Just add 1 to it. I'm actually confused. How am I confused? Yeah. So you're actually meant to increment this, right? For some reason, I can't point my hand on why. Why am I passing this? Okay, I think yeah. I mean, state itself is actually non-mutable, so you need to find a way to actually make it immutable, right? Copy with gives you the opportunity to actually do that. So I guess, right, maybe I'll have to I've forgotten how to use qubits. But yeah, someone is raising. Please go ahead. If you have any questions, just unmute and ask. Sorry, time.
Good evening, everyone.
Yeah.
Please, can you go back to the code where you write block provider? Like,
Okay.
I want to ask, like, is he that block provider? Is it necessary that it will be at the particular screen we want to use, or is this something that will be at
Yeah.
the root of the
So
project?
yeah. So that's the part like is like the more advanced part. But yeah, it doesn't have to be here, right? You could make it global. There are different ways to actually access a block's values and methods, right, or qubits, right? There are different ways to access it. Something called block access. If you actually check the documentation, you see it. Well, yeah, it doesn't have to be here. It could be global, right? It could be here. You could define it here. Uh, there's something called the multi-block provider, but if you were to do this, you would do counter qubits. Right. So now it's available globally. Right. So it doesn't really matter what particular page you are on. You'll be able to access the values from there because it's defined at the root of the application. That's a material app. So any value anytime you call counter qubit, if you don't do this, it's going to work because it's available globally. But if you do this and you say you have another page like something else, right? You would need to define this one like globally or pass down the variable because you don't want to have you don't want to initialize two different block states, right? But yeah, I think that answers your question. Does that answer your question? All right. Any other question? One has any other question? No problem. So the thing is, there are more advanced ways to actually do this, to actually handle those things. Like I actually listed them here, but that's what I said. So this is actually meant to be the basics, right? Well, I mean, it's not even enough time to actually go into the complex one. But yeah, yeah. Any other question? You have any other questions? I think we're already past time. Miriam, I think we're done for now.
Okay. So no one has questions, right?
So,
If you have questions, ask now before we end the call. Okay. So we don't have any questions from any other person. Thank you so much. Thanks for this. You really start from like the scratch actually. You started
yeah,
from
it's
the scratch,
from
and I
scratch.
hope
I was thinking about.
everyone there was able to
Go
get
on.
one or two from the whole session, right?
Yeah.
Apologies everyone. I've not been able to like upload our videos on YouTube for those of us that want to always go back. But I promise that I will upload everything this week. And there's also going to be another class tomorrow. We'll be sending the link. I'll share the link already, but I'll be dropping the link again so that we can all, join once the class starts. So I'll see you in the next class, which is tomorrow.
Um,
Bye.
Bye. Bye, everyone.